Alright, students, welcome back for day 2 of me being gone. I know you miss me so much, but it's gonna be okay. The bell work for today. I want you guys to write and balance the neutralization of calcium hydroxide and carbonic acid. So we have an acid and a base, and when we throw them together, this is going to be called a neutralization reaction. So, take a second, have the substitute pause the video, and give out his stamps for your bell work. And when most people are finished, we will go ahead and resume the video and figure out this bell work. Alrighty, let's resume. We are going to add carbonic acid, H2CO3, and calcium hydroxide. What will we form here? We are going to swap the positive ions, and we are going to, I messed up there. We are swapping the positive cations, and we will swap the negative anions. And what we get is H2O. Remember, neutralizations, we will always get water, H2O. And let's look at how calcium, a +2 alkali earth metal, crosses a carbonate ion, which has a -2 charge. They both have -2. So when they crisscross, they are going to cancel each other out. And we will be left with our salt here, calcium. And I'm going to run out of room, so I'm going to write it below. Calcium carbonate, CaCO3. So, notes today are very short. Let's look at the first slide, acids and bases. We are going to look at how we can use neutralization reactions along with a term we learned way back when called stoichiometry. And we used to know that stoichiometry was a way to relate two chemical species via a mole-to-mole ratio, which kind of bridges the gap between two chemical species. So what we're going to do is apply writing a neutralized reaction, a balanced neutralized equation, and we're going to look at how we can look at the concentration of one to determine the other. That's what a titration is, and that's what we talked about yesterday. Okay, so we're going to be able to find concentrations. That's our goal. Let me use the pen here. We're going to be able to find concentrations of these acids and bases when they are titrated with a known solution, or what we called a standard solution yesterday. We are going to use dimensional analysis. Oh boy, how fun does this sound? Dimensional analysis, and when I think dimensional analysis, I think T-chart, and I think conversions. We're going to have something, we're going to do some conversions to cancel our units, and we're going to end up with something that we want. So, we got 3 examples, and that will be notes for today, short, sweet, and to the point. Hopefully you got a stamp for your homework worksheet 1. If not, make sure you do that before the end of the class. We're going to do 3 examples here, and then you're going to have the rest of the class to finish worksheet number 2 of your homework packet, and you will be getting a stamp on that on Wednesday, tomorrow. Okay, so let's look at this first example. Start by reading the question. What is the concentration of 50 milliliters of a NOH, or sodium hydroxide solution, that is neutralized by 30 milliliters of a 0.5 molar hydrochloric acid? So what we know from this problem is the concentration of hydrochloric acid, and we know exactly how much we have of it. What we're looking for is the concentration of this unknown molarity of a solution. We have 50 milliliters of it, but we don't know the concentration. So that's what we're trying to find via this titration. And we're going to do a lab when I get back. And we're going to actually titrate and see how this works in the real life. So we're going to apply the skills that we have learned already, and we are going to write our neutralization reaction. And you guys don't have a whole lot of space, so if enough people request, I'd have the substitute pause the video, and he can use the extra paper that I have stored in my third drawer down on this island desk here. If you guys need an extra sheet of paper to work, I know I didn't give you a whole lot of room on these notes. So take time to do that if you need to, otherwise I'm going to continue. So we are mixing HCl and sodium hydroxide. And I'm not going to take the time to crisscross everything, but we form water and a salt. In this case, we are going to form our table salt, NaCl. And sodium had a +1 charge, chlorine -1, so that canceled nicely. Everything is balanced. You need to balance your equation. I am going to then take and write what I know underneath each one. I know that I have 50 milliliters of NaOH. I know that I have 30 milliliters of a 0.5 molar solution of HCl. So I'm going to set up my nice straight line for my dimensional analysis, and I'm going to start out with the 30 milliliters of hydrochloric acid, and that's where we're usually going to start out here, with the volume of our standard solution. So start out with the volume, and we want to use stoichiometry to go from one chemical species into the other. We want to go from hydrochloric acid to sodium hydroxide. So we are going to use the molarity to go get to moles. But first, molarity, remember that molarity is moles per liter. So we are in milliliters. Let's get to liters first. There are 1,000 milliliters in 1 liter. Now we can use our molar conversion. So I'm going to pull a different color here. So in 1 liter, oh, that's a terrible color. Let's use orange. In 1 liter, there are 0.5 moles, and we got that from our standard solution. 0.5 moles per liter is the molarity. So I am in moles of hydrochloric acid. So this is HCl, HCl, HCl. Now I'm going to use a mole-to-mole ratio to go from HCl to NaOH. There is 1 mole of HCl for every 1 mole of, and what am I trying to find? Well, I want to go into NaOH. That's what I'm after. So now I've gone from HCl into NaOH. I have made that bridge. That's called stoichiometry right there, that mole-to-mole connection right here. This is stoichiometry, and we took a whole unit to study that. And now that we have moles of sodium hydroxide, let's get an answer with that. So the number of moles would be 0.015 moles of NaOH if you calculated that out. And what we want to do is take moles and find the concentration, right? This is just moles. We need to find molarity, moles per liter. So I'm going to take 0.015 and divide it by my amount in liters. Okay, I have 50 milliliters right here, but I need it to be in liters, so I would need to convert that into liters, which would be 0.05 liters. And I'm going to get a concentration of 0.3 molar for sodium hydroxide. And that is how we find the concentration via a titration. Next example, we are going to determine the concentration of acetic acid if 25 milliliters of it required 38.2 milliliters of a 0.1 molar sodium hydroxide solution to reach the equivalence point in a titration. Let's start by writing our equation. We have acetic acid, which is HC2H3O2, and we are going to add it with sodium hydroxide, and we form water, and acetate has a -1 charge, So does sodium has a +1 charge, so it will be Na(C2H3O2), sodium acetate. And if we remember the solutions that I had heated up and I dropped a crystal in when we were talking about solubility rules, that was sodium acetate. So I'm going to write what I'm given. Let's see. Determine the concentration of acetic acid if 25 milliliters of it required 38.2 milliliters of a 0.1 molar solution. So 25 milliliters required 38.2 milliliters of 1 molar to reach the equivalence point. Alrighty, so here we go. Here's my dimensional analysis. I'm going to start with 38.2 milliliters of NaOH. I'll write it above here, NaOH. Let's get into liters first. 1,000 milliliters in 1 liter. And we're going to use our molarity here. So there is 0.1 moles per 1 liter. And now we're in moles of sodium hydroxide, so now we can do a mole to mole ratio. But something we didn't do was make sure that our equation was balanced. And here we got lucky because it was. Sometimes we may need to make sure that our equations are balanced. So we're lucky we have a 1 mole of NaOH to a 1 mole of acetate, or sorry, acetic acid, HC2O3, whoops, I am all over the place here, C2H3O2. And now that I am in moles of acetic acid, which if you calculate that, you get something like 0.00382 moles of acetic acid, HC2H3O2. Okay, so what we want to do is put that into a concentration. I'm going to take 0.00382 and divide it by 0.025 milliliters. Oh, sorry. I had put milliliters into liters here. And that equaled a concentration of 0.153 molar. And then if I can squeeze it in here, HC2H3O2, acetic acid. So there is your answer right there. This is the last example of the day. After this, you will have the rest of class to work on worksheet number 2. We have 35 milliliters of a 3 molar HCl solution, and it is titrated with 2.5 molar sodium hydroxide. What volume of sodium hydroxide is required to reach the equivalence point? So this time we're given the concentration of our unknown. We want to find what the volume would be. So let's go through that. First, we need to write out our equation. HCl plus NaOH will yield water and sodium chloride. And that is all balanced out. I have a 2.5 molar solution. I'm looking for the volume. And that could be in liters just because molarity is in liters. I'm given 35 milliliters of a 3 molar solution here. Let's do dimensional analysis and figure this out. So I'm going to start with 35 milliliters of HCl. I'm going to go into liters using 1,000 to 1. Now I can use my molarity. There are 3 moles per liter of HCl. Now I can do stoichiometry. I have a 1 mole to 1 mole ratio of HCl to sodium hydroxide. So here's my stoichiometry. And now I'm going to use my molarity, 2.5 moles per 1 liter of solution. So there's my molarity for sodium hydroxide. And what's going to happen is units will cancel and I'll be left with liters. And I actually get 0.042 liters of sodium hydroxide. And I'm finished. So we're done with notes. Rewind the video, pause it if you want to go back and look at what I did and what my process was. Otherwise, use your notes, use the examples to complete worksheet number 2. That will be stamped at the beginning of class on Wednesday.